Hello students. So today I am doing class for class 12. The topic is the same topic, that is matrix. So in the last online class also we were doing the same topic, that is matrix. So this is your continuation class. So we are doing the problems, that is page number 134, same exercises. Each question carries 4 marks. Okay, the question is question number 17. So in the last online class we did question number 16. Okay. So now question number 17 is, if A is equal to, this is 2 cross 4 matrix. This matrix is of order 2 cross 4. That means 2 rows and 4 columns. 1, minus 3, 4, 2, 0, 5, minus 2 and 3. And what is B is equal to? Minus 5, 0, 6, minus 4, 7, 8, minus 2, 5. So you have to find out a matrix X of order 2 cross 4 such that 3A minus 2X is equal to B. So here matrices A and B are given, and also you have to an equation is given out here, that is matrix equation is given out here, that is 3A minus 2X is equal to B. So using this matrix equation you have to get the matrix X. Okay, so let us write down the given matrix, that is matrix equation. That is matrix equation is given here. So given matrix equation is, what is it? 3A minus 2X is equal to B, right? Or 3 into, what is A out here? It is 1, minus 3, 4, 2, then 0, 5, minus 2, 3. This is the given matrix A. Minus 2X is unknown matrix. Again you write down the matrix B. What is it? It is minus 5, 0, 6, minus 4, and next one is 7, 8, minus 2 and 5. This is the given matrix B, right? So now in this case you can multiply all these elements by 3, because 3 is the scalar multiplication of this matrix, isn't it? So, or now here multiply by 3, 3 1s are 3, this is minus 9, 3 4s are 12, 3 2s are 6, right? 3 1s are 3, 3 into minus 3, minus 9, 3 4s are 12, 3 2s are 6, 3 zeros are 0, 3 5s are 15, 3 into minus 2, minus 6, 3 3s are 9. Is that clear? So minus 2x remains same, is equal to, and this right hand side matrix also remains same, that is minus 5, 0, 6, minus 4, right? And it is 7, 8, minus 2 and 5. Is that clear? So now this is just like an equation. Let us take this matrix to the right hand side. It becomes minus, isn't it? So now let us solve this equation. Or minus 2x is equal to, so what is the right hand side matrix here? Minus 5, 0, 6, minus 5, 0, 6, then minus 4, then 7, 8, 7, 8, minus 2, 5, minus 2, 5, right? Then take this matrix to the right hand side, becomes minus sign, isn't it? It is just like an equation. It is just like solving an equation, right? Minus 3, then it is minus 9, 12, 6, right? It is 12, 6. Is that clear? Next, second row is 0, 15, 0, this is 15, minus 6, 9, minus 6, and this is 9. So is that clear to all of you? So let us simplify it again. So, or it is minus 2x is equal to, first matrix remains same, 5, 0, 6, minus 4, 7, 8, minus 2, 5, then right here plus. So this is your, actually if there is only minus sign, there is minus 1. So minus 1 is the scalar multiplication of this matrix. So multiply throughout the term by minus 1. So what do we get? Minus 3, minus into minus, plus 9, usually plus 8 we don't write, then minus 12, right, minus 3, 9, minus 12, minus 6, this is minus 6, again minus 0 is 0, this is minus 15, this is plus 6, and the last one is minus 9. So I think you have understood it, okay? So let us simplify it. Or minus 2x is equal to, you can add those two matrices because they are of same order, right? So what do we get? Corresponding elements should be added. First element should be added, that is minus 5 minus 2 is minus 8. Then 0 plus 9, 9, 6 minus 12. This is minus 6, isn't it? Minus 12 plus 6 is minus 6. And minus 4 minus 6, same sign, you have to add them, minus 10. And again 7 plus 0 is 7. 8 plus minus 15 is minus 7, right? Then minus 2 plus 6. 6 minus 2 is 4. 6 minus 2 is what? 4. And minus 9. Minus 9 plus 5 is minus 4. Is that clear? So let us take it once again. Minus 5 minus 3, same sign, minus 8. 0 plus 9 is 9. 6 minus 12, different sign, you have to subtract. Minus 6, you have to write on the sign of the greater number. So minus 4 minus 6 is minus 10. 7 plus 0 is 7. 8 minus 15 is minus 7. Minus 2 plus 6 is 4. And 5 minus 9 is minus 4. Right? So what is the value for x now? What is the matrix x now? Is equal to, when this minus 2 goes on the right hand side, it becomes minus half. So it is minus half. Then write on the matrix here. 8, 9, minus 6, minus 10, and then 7, minus 7, 4, minus 4. So I think you have understood it. So when this minus 2 into x is there, so when this minus 2 goes to the right hand side, it becomes minus half, right? Minus half. Then it is, this one is minus 8. This is your minus 8, 9, minus 6, minus 10. 7 minus 7, 4 minus 4, right? So minus half is the scalar multiplication of this matrix. You have to multiply all these elements by minus half. Then you can get the answer, right? So, or x is equal to, multiply by minus half there. Minus into minus plus half into 8. 4. Then minus 9 by 2. 9 is not divided by 2, that's why write minus 9 by 2. Then plus 3, 2 3s are 6, minus 2 minus plus 5, 2 5s are 10. So it is also minus 7 by 2, 7 is not divided by 2. This is minus 2 minus plus 7 by 2, alright. And next one is minus half into 4, that is minus 2. Minus half into 4 is minus 2. Then minus half into minus 4, that is minus 2 minus plus 2. So this is the final answer. Let us check it once again. Minus 2 minus plus 4, minus 9 by 2, minus 2 minus plus 3, plus 5, minus 7 by 2, plus 7 by 2, minus 2, and then plus 2. So this is the final answer. So we have got the matrix X. Okay. So you can copy it. We'll do this now. So now we will do the next question, that is question number 19. So this is very important question. So number 19 is, if A is equal to second order matrix, that means 2 rows, 2 columns. First row 1 minus 1, second row 2 minus 1. B is equal to A1 B minus 1, and it is given that A plus B whole square is equal to A square plus B square. Okay, so you have to find out A and B, small a and small b. You have to get the values of small a and small b. So let us find out first a plus b, right? So therefore a plus b is equal to, what is a here? 1 minus 1, 2 minus 1, plus what is b? A1 b minus 1. So we can add those two matrices because they are of same order, right? So we can add those two matrices. Corresponding elements will be added. 1 plus A and minus 1 plus 1, that is your 0. And this is 2 plus B. This is your 2 plus B, and minus 1 is minus 2. That is your A plus B. So now let us write down this given now. So here again, here given is, what is given here? A plus B whole square is equal to A square plus B square, right? So this is given. Matrix A plus B whole square is equal to matrix A square plus matrix B square, right? So what is A plus B whole square here? It should be A plus B into A plus B, right? So which is equal to, what is A square? A dot A plus B dot B. So let us put the value. What is A plus B out here? What is A plus B? 1 plus A, 1 plus A, 0. Then this is 2 plus B, 2 plus B, and it is minus 2. Again repeat that. What is A plus B? It is 1 plus A, 0, and it is 2 plus B minus 2, right? So which is equal to, what is A? A dot A, 1 minus 1, 1 minus 1, 2 minus 1, 2 minus 1, right? 1 minus 1, 2 minus 1. Again, what is A? Again, you have to repeat it. 1 minus 1, 2 minus 1. Is that correct? 1 minus 1, 2 minus 1. Okay? Since there is no space for B dot B, let us write it in the next step. But this is your continuation part. Plus, what is B dot B? It is A1B minus 1. A1B minus 1, right? Again, dot A1B minus 1. A1B minus 1. So I think you have understood it. So let us simplify it now. So, or, now you have to multiply these two matrices. You know how to multiply them, isn't it? So first row by first column. So how much is it? First row by first column, 1 plus A into 1 plus A. 1 plus A whole square. Right? 1 plus A into 1 plus A, 1 plus A whole square. First row by first column. 0 into 2 plus B. That is plus 0. Actually, you don't have to write it. Okay? Again, first row by second column. 1 plus A into 0. 0. 0 into minus 2. Plus 0. Is that clear to all of you? So I think you have understood it. That is first row by first column. 1 plus A into 1 plus A. 1 plus A whole square plus 0 into 2 plus B. That is 0. Again, first row by second column. 1 plus A into 0 is 0. Plus 0 minus 2 is 0. Alright. Is that clear now? So next, second row by first column. That is, it will be 2 plus B into 1 plus A. 2 plus B into 1 plus A. Right? Then, minus 2 into 2 plus B. This second element should be multiplied by the second element of the first column. That is, second row by first column. 2 plus B into 1 plus A. Then minus 2 into 2 plus B. This is the single element, right? Let us write it here, 0 plus 0. This is the second element. So now again, this second row should be multiplied by second column. Corresponding elements should be added, right? 2 plus B into 0, 0, right? 2 plus B into 0, that is 0. Minus 2 into minus 2, plus 4. So this is your left hand side matrix. Is that clear? So which is equal to, now next, you can multiply these two matrices again. So what is this product now? First row by first column. 1 ones are 1. Minus 1 into 2 minus 2. Right? Next, first row by second column. This first row by second column. 1 into minus 1, minus 1, minus 2 minus plus 1. Clear? So next one is, again, this second row by first column. Second row by first column. 2 ones are 2. This is minus 2. Right? Next, second row by second column. 2 into minus 1, minus 2, minus 2 minus plus 1. So this is your product of these two matrices. Right? Plus, again you have to multiply these two matrices next. Again, first row by first column. First row by first column. Corresponding elements must be multiplied. A into A square, plus B, right? A into A is A square, plus, how did you get that B? 1 into B is plus B. Again, first row by second column. A1s are A. This is A into 1 is A, then 1 into minus 1 is minus 1. Right? So next. Next one is, this second row should be multiplied by first column now. Corresponding elements should be multiplied. A into B is AB. It is AB, minus 1 into B, minus B. Is that clear? And what is the last one? This second row should be multiplied by second column. Corresponding elements should be multiplied. B1s are B, then minus 2 minus plus 1. So that is your matrix. Okay? So I think I have understood it. So let us simplify it. So now we have to simplify it. Or now this is your 1 plus A whole square only. Now this remains same. Don't simplify it. 2 plus B, 1 plus A, minus 2 into 2 plus B, right? So 0 plus 0 is 0, 0 plus 4 is 4. Okay, so it is equal to, now on the right hand side, 1 minus 2 is minus 1, this is 0, this is 0, this is minus 1, right? Next, plus this second matrix, A square plus B, A minus 1 remains same, AB minus B, and this is your B plus 1. Got it? So this right hand side can be simplified further. This right hand side can be simplified further. Okay? So left hand side remains same. 1 plus A whole square. This is 2 plus B into 1 plus A minus 2 into 2 plus B. This is the first column, and this is the second element of the first column. Next, 0, 4. These are the elements of the second column. So is equal to, you can add those two matrices because they are of same order. So corresponding elements should be added. So it is A square plus B minus 1. Then A minus 1 plus 0 is A minus 1. So this is 0 plus AB minus B is AB minus B. And then minus 1 plus B plus 1. That is 1 gets cancelled. You get only B here. So I think you have understood it. So now, these are the two matrices which are equal. So from the definition of the equality of matrices, you can equate the corresponding elements, right? So which elements will you equate now to get the values of A and B? Because so in this problem, you have to get the values of A and B, okay? So this 0 is equal to A minus 1. It will be easier for you to get the value for A if you equate 0 with A minus 1. So therefore 0 is equal to A minus 1. Or what is the value for A? A is equal to 1. So we have got the value of A is equal to 1. Again you can equate 4 with B. Isn't it? 4 with B, that is, therefore 4 is equal to B. Or you can write B is equal to 4. That means we have got the answer. That is A is equal to 1 and B is equal to 4. So these are the answers. So I think you have understood it. Okay. So we'll do the next question now. Now, we will do the next question, that is question number 21. If A is equal to, this is also second order matrix, 2 rows and 2 columns, x minus 2, 2 and 1. B is also the second order matrix, 2 rows and 2 columns, 3, 4, 0, 1, and C is also the second order matrix, that is minus 1, minus 2, y, 2. And also an equation is given out there, that is A plus B is equal to BC. So you have to find out x and y. Right? So let's do this problem. So the solution is, so here also an equation is given. What is that equation? A plus B is equal to BC. A plus B is equal to BC. Or what is A out here? This is x minus 2, 2, 1, right? And plus, what is B in this case? 3, 4, 0, 1. That is your B. Is equal to, what is B now? Again, this is 3, 4, 0, 1, 3, 4, 0, 1. And what is C now? It is minus 1, minus 2, y, 2. Okay, so we have copied it. Now you can do addition of matrices and multiplication of two matrices. Okay, so on the left hand side you can add those two matrices because they are of same order, you know that, right? So it is x plus 3 and this is minus 2 plus 4 is 2, right? 2 plus 0 is 2 and 1 plus 1 is also 2 is equal to. So now in this case you can do the matrix multiplication, that is row by column. Okay, so now this first row should be multiplied by the first column. Corresponding elements can be multiplied. 3 into minus 1 minus 3, then plus 4y, right? 3 into minus 1 minus 3 plus 4y, right? Again first row should be multiplied by the second column because there is second column again. 3 into minus 2 minus 6 plus 4 to 0. This is your 8, right? Again, this second row should be multiplied by the first column. Corresponding elements should be multiplied. 0 into minus 1, 0, plus y into 1 is y, right? 1 into y is y. Next one, again, this second row should be multiplied by the second column. 0 into minus 2, 0, plus 2 ones are 2. So I think you have understood it. So let us simplify it once again. So let us simplify it. So or, now this is your x plus 3, 2, 2, 2 is equal to, now here you can write 4y minus 3, 4y minus 3, then 8 minus 6. What is 8 minus 6? 2, 0 plus y. Y, 0 plus 2 is 2. Okay. Now, these are the equality of two matrices. And from the definition of the equality of two matrices, you can write down their corresponding elements are equal. That means their corresponding elements must be equal. This 2, 2, 2, 2, they are okay. Now y is equal to 2. Therefore, we get y is equal to 2. Again, you can equate the first elements on both the matrices. That is from the first row. That is x plus 3. You can equate these two elements again. That is, this is the first element of the first row, this is the first element of the first row, and they are on the opposite sides. You can equate them because this is the equality of two matrices. So x plus 3 is equal to, this is your 4y minus 3. Right? X plus 3 is equal to 4y minus 3. Next, you can put the value for y here. X plus 3 is equal to 4 into 2 minus 3, or x plus 3 is 4 to 8 minus 3, or now x plus 3 is equal to 8 minus 5 is 8 minus 3 is 5, or x is equal to, this is 5 minus 3, or what is x is equal to, that is 2. So we got the values x and y. Okay, so write down the answers. X is equal to 2, y is also 2. So this is the answer. So I think you have understood it, so you can copy it. We'll do the next question now. So now we will do the next question, that is question number 22. If A and B are two matrices such that AB is equal to O, that is O is the null matrix or the zero matrix, can we deduce that either A or B is a zero matrix? Illustrate by an example. So in the question it is given that A and B are two matrices such that AB is equal to O. So can we deduce that either A or B is a zero matrix? Either A or B, either A or B is a zero matrix. So it is not necessary that if AB is equal to 0, either A or B is a zero matrix. It is not necessary, right? If A and B are two matrices such that AB is equal to null matrix, so it is not necessary that either A or B is a zero matrix. Let us illustrate it by an example. Let us consider the example. So suppose A is equal to 2 minus 2 minus 2, 2. So this is not your zero matrix. Again, B should not be the zero matrix. B is equal to, let us write minus 1, 3, minus 1, 3. Okay? Both are not the zero matrix. But if you multiply these two matrices, A and B, you will get the zero matrix. So it is not necessary that A or B is a zero matrix, for AB should be equal to null matrix. Is that clear? So suppose if A and B are two matrices such that AB is your null matrix, so it is not necessary that either A or B is a zero matrix. Let us do an example. Both are non-zero matrix. A is also non-zero matrix, B is also non-zero matrix. But you can show that these two matrices is a zero matrix. Okay? So let us multiply them. Therefore, AB is equal to 2 minus 2 minus 2, 2. Then there is minus 1, 3, minus 1, 3. So let us multiply them. Okay, so let us multiply them, which is equal to, now let us multiply them first row by first column. This first row by first column, corresponding elements should be multiplied. 2 into minus 1, minus 2, right? Then second element into second element, that is plus 2. Is that clear? Again, second column is there, you have to write down the second element of the first row. This first row should be multiplied by this second column. 2 into 3, 6, right? Minus 2 into 3, minus 6. This is your minus 6. Is that clear? 2 into minus 1, minus 2. Minus 2 into minus 1, plus 2. Is that clear? Next, this first row should be multiplied by second column. 2 3s are 6. Minus 2 into 3, minus 6. Is that clear? So this is your first row. Next, this second column, this is second row should be multiplied by first column. That is minus 2 into minus 1 plus 2. Then 2 into minus 1 minus 2. Is that clear? Next, this second row should be multiplied by second column, but corresponding elements should be multiplied. Minus 2 into 3, minus 6. Let us write minus 6 here. And then this second element should be multiplied. 2 3s are 6, that is plus 6. Is that clear? Again, let us check it. This second row should be multiplied by second column. Minus 2 into minus 1. Minus 2 into minus 1 plus 2. Minus 2 into minus 1 plus 2. 2 into minus 1 minus 2. Again, this second row should be multiplied by second column. Corresponding elements should be multiplied. Minus 2 into 3 minus 6 plus 2 into 3 is 6. Right? So you can simplify it. So which is equal to, this is 0, 0. That is minus 2 plus 2, 0. 6 minus 6, 0. This is also 2 minus 2, 0. Minus 6 plus 6 is 0. Which is equal to norm matrix. So if AB is equal to norm matrix, then it is not necessary that either A or B is a zero matrix. So we have illustrated it by an example. So this is an example, right? So you have to write down last one, that is, at last you have to write down, in the next step you'll write if AB is equal to norm matrix, then it is not, if AB is a norm matrix, then it is not necessary that either A or B is a zero matrix. So this is the answer. So we have illustrated it by an example. So I think you have understood it. So we'll do the next question now. So now we'll do the next question, that is 23 number 2. If A is equal to, this is also second order matrix, first row 2 minus 1, second row 3 2, and B is also the second order matrix, 2 rows and 2 columns, first row 0 4 and second row minus 1 7. You have to find out the matrix 3A square minus 2B plus 1. Okay, so let us write down that given expression, 3A square minus 2B plus I. Okay, so which is equal to 3 into, this is your A dot A minus 2B plus I. So let us find out this matrix is equal to, what will you write? 3 into, what is A out here? What is A? This is 2 minus 1, 3, 2, right? Again, you have to write the matrix A, that is 2 minus 1, 3, 2, right? Then 2 minus 1, 3, 2. 2 minus 1, 3, 2. Minus 2 into, what is B out here? It is 0, 4, minus 1, 7. This is your B matrix. Plus, what is I here? You know that I is an identity matrix of order 2. This should be also of order 2. So what is the identity matrix of order 2? It is 1, 0, 0, 1. Leading diagonal should be 1. Plus the elements in the leading diagonal should be 1 always. So this is an identity matrix. So it is 0, 0. So I think you have understood it. So I is not given. It is understood that I is an identity matrix of order 2. So the leading diagonal should be 1, 1 and all other elements should be 0. Right? So now you can multiply it. Is equal to 3. Let us multiply them. First row by first column. You know that. Corresponding elements should be multiplied. 2 2s are 4. Minus 1 into 3. Minus 3. Right? Again, second column is there. You have to write down the second element of the first row. Again, first row by second column. Corresponding elements should be multiplied. 2 into minus 1, minus 2. Right? Minus 1 into 2, minus 2. Is that clear? Next, this second row should be multiplied by first column. Corresponding elements should be multiplied. Okay? 3 2s are 6 plus 2 3s are 6. Right? Again, this second row should be multiplied by this second column. Corresponding elements should be multiplied. 3 into minus 1, minus 3 plus 2 2s are 4. Understood? So, this is your matrix multiplication. Okay? This is 2 2s are 4, minus 3, minus 2, minus 2, 3 2s are 6, plus 2 3s are 6, minus 3 plus 4. So, it's correct. So, now again minus 2 is the scalar multiplication of this matrix. You know that, isn't it? So, minus 2 should multiply all the elements in this matrix. So, plus minus 2. Minus 2 into 0, 0. Minus 2 into 4, minus 8. Right? Minus 2 into minus 1, plus 2. Minus 2 into 7, that is your minus 14. Right? Make it plus. Multiply all these elements by minus 2. Minus 2 into 0, 0. Minus 2 into 4, minus 8. Minus 2 into minus 1, 2. And minus 14. Plus. Then last one is 1 0 0 1. Plus this is your 1 0 0 1. So I think you have understood it. Okay. So let us simplify it. So is equal to, this is your 3. What is 4 minus 3? 1. Minus 2 minus 2. Minus 4. 6 plus 6. 12. Minus 3 plus 4 is 1. Right? Next, you can add these two matrices. Addition of two matrices. They are of same order. You can add them. So 0 plus 1 is 1. Minus 8 plus 0 is minus 8. Right? Then 2 plus 0 is 2. And minus 14 plus 1 is minus 13. Is it clear to all of you? So 0 plus 1 is 1. Minus 8 plus 0 is minus 8. 2 plus 0 is 2. Minus 14 plus 1 is minus 13. Right? Again you can add them. Which, don't add them because there is 3 here. 3 is the scalar multiplication of this matrix. You have to multiply all these elements by 3. So it is 3 ones are 3. This is minus 12. This is 36, isn't it? 3 12s are 36. 3 2s are 6. 3 1s are 3. This is 3 1s are 3. Plus, now it is, this is your 1. This is minus 8. This is 2 and this is minus 13. Right? So now you can get the matrix by addition of these two matrices. You can add those two matrices. So what do we get? 3 plus 1, 4, minus 12, minus 8, minus 20, minus 12, minus 8, minus 20, 36 plus 2. That means it is 38. And 3 minus 13, difference sign, you have to subtract it. And you have to write down the sign of the great number, that is minus 10. So this is the final answer. So I think you have understood it. So you can copy it. We'll do the next question now. Now we will do the next question, that is question number 24. Find the value of x such that this is your row matrix. Only one row is there, so this is the row matrix 1x1, and this is the third order matrix. That is in the first row 1 3 2, second row 2 5 1, and third row is 15 3 2. Into this is the column matrix, because only one column is there. So it is 1, 2, x, which is equal to 0. So this is the given part. Okay. So now, first of all, you multiply the first two given matrices. This first matrix will be multiplied by the second matrix. Okay. So this is the given part. So can you multiply it? So for the first matrix, you have to check the number of columns, and for the second matrix, you have to check the number of rows. So what is the number of columns for the first matrix? It is 3 columns. And what is the number of rows for the second matrix? That is 3 rows. That means number of columns is equal to number of rows. That means you can multiply these two matrices. Okay. So, or let us multiply those two matrices. First row by first column. First row by first column, corresponding elements should be multiplied. 1 1s are 1, x 2s are 2x, plus 1 15s are 15. So let us write 1 1s are, this is what? 1 1s are 1, plus x into 2, 2x, plus 1 into 15, 15. That is the first element of the first row. Okay. Again, second column is there, so we can write down second element of the first row. So this first row should be multiplied by the second column. So corresponding elements should be multiplied. That is, again, 1 3s are 3, plus 5x, plus 5x, plus 1 3s are plus 3. Is that clear? And the next one is, what is the next one now? This first row should be multiplied by this third column. This first row should be multiplied by third column, but corresponding elements should be multiplied. So 1 2s are 2, 1 2s are 2, plus x 1s are plus x, plus 1 2s are 2. Is that clear? That is 1 2s are 2 plus x into 1. Second element should be multiplied. It is x, x 1s are x, plus 1 2s are 2. So this is the only matrix. That is, this is known as the row matrix. Okay. So there is only one row. Then what is the second matrix here now? Or what is the third matrix? It is 1 2x, which is equal to what? It is 0, null matrix. Now again, these are the two matrices to be multiplied. Can you multiply them? For the first matrix, how many columns are there? 3 columns. For the second matrix, how many rows are there? 3 rows. That means they are equal. Number of columns of the first matrix is equal to number of rows of the second matrix. They are equal. So you can multiply them again. Okay, but let us simplify it first. 15 plus 1, 16 plus 2x, right? This is 3 plus 3, 9 plus 5, 3 plus 3, 6. This is 15 plus 1, 16 plus 2x, 3 plus 3, 6 plus 5x. This is 2 plus 2, 4 plus x. And then into, there is column matrix 1 2x, which is equal to the null matrix. Now again you can multiply them, because number of columns of the first matrix is 3 and number of rows of the second matrix is 3. That means they are equal. That means you can multiply them. So this first row should be multiplied by the first column. You will get only one element in the new matrix. Okay. So or now this first row should be multiplied by the first column only. First element should be multiplied. 16 plus 2x into 1 is 16 plus 2x plus. Now second element should be multiplied by second element. That is 2 into 6 plus 5x plus. Now this third element should be multiplied. X into 4 plus x. X into 4 plus x. Third bracket is closed. So this is the only matrix here. So this matrix contains only one element. And this is your null matrix. Okay. So I think you have understood it. So this is only 16, right? So now let us simplify it once again. Or this matrix is 16 plus 2x plus multiply by 2, 2 6 are 12 plus 10x, right? Then plus 4x plus x square. 4 into x, 4x plus x into x square is equal to null matrix O, right? So now you can add them. This is the only x square here, right? X square first, then plus 4x plus 2x, 6x plus 10x plus what? How much is it? It is 16x, isn't it? 10 plus 4, 14 plus 2, 16x, right? Plus 16 plus 12, that is 28. 28. Third bracket closed is equal to. So now this is the matrix, and this matrix contains only one element. That means it is of order 1 cross 1. 1 cross 1. 1 row, 1 column. 1 row, 1 column. 1 into 1, that is only one element is there. So this null matrix should be of same order here. So it is also within third bracket. There is only 1, 0. Because this is of order 1 cross 1. This matrix contains only one element. So it is of order 1 cross 1. So this null matrix should be of order 1 cross 1. That is within matrix M there is only 1, 0. So now these are the equality of two matrices. So you can equate the two elements. That means this first element is equal to first element only. So x square plus 16x plus 28, which is equal to 0. So you can equate the elements only, because this is the equality of two matrices. That means these two elements must be equal, right? So let us solve it. You can factorize the left hand side, middle term breaking. If you multiply the two numbers, you should get 28. Okay, so before 28, plus sign is there. That means you have to find out that two numbers whose multiplication is 28, and after adding you should get 16, because before 28 there is plus sign. So adding that two numbers you should get 16. If you multiply that two numbers you should get 28, and adding that two numbers you should get 16. What are those two numbers? 14 2s are 28 and 14 plus 2 is 16. So or it is x square plus this is 14 plus 2 into x plus 28, which is equal to 0. 14 plus 2 is 16, 14 2s are 28. Or x square plus 14x plus 2x plus 28, which is equal to 0. Is that clear? Now let us simplify it. Or x is common, or x is common from the first two terms, isn't it? So it is x plus 14. Again from the next two terms, what is common? Plus 2. So within bracket what do we have? X plus this is 14, which is equal to 0. Right? So again what is common out here? It is x plus 14 into x plus 2, which is equal to 0. Now we can write either or. So either product of two factors is equal to 0. That means first factor is equal to 0 or second factor is equal to 0. Either x plus 14 is equal to 0 or x plus 2 is equal to 0. So from the first equation, what is the value for x? X is equal to 14, sorry, minus 14, x is equal to minus 14, or x is equal to minus 2. Or x is equal to, this is your minus 2. So we have got the answer. So you can write down the answers as, so you can write down the answers as x is equal to minus 14, or this is minus 2. So these are the answers. That is, x is equal to minus 14 or x is equal to minus 2. Okay. So this much is for today. So you also, today also we did some problems. So you revise all the problems that we did today. Okay. and you revise all the problems that we have done so far. Okay, so this was it for today. So in the next class we'll do more problems on matrix, right?